Hi guys. Today we only have the one video. Our title for today is at the top of the slide 2-5, using linear models. So that's the title of today's section. And then go ahead and pause the video so that you can write down this problem. You do need to write down both the sentences as well as the table. On the table, make sure to also write down the headings so that you understand what each column is representing. This is a word problem, so all of the numbers have a meaning, and we need to know what that meaning is. While you're writing, I'm going to go ahead and read out loud, and if you need more time, pause, and then we'll move on. So this problem says the table below shows the approximate percent of students who sent applications to 2 colleges in various years since 1985. So the X column is years since 1985. 0 would mean the year 1985. 3 would mean 3 years later, so 1988. And then the Y column is the percentages. Make a scatter plot of the data and draw a line of best fit. And then describe the correlation. So here we have our table from our first slide. And when you're given a table, the first column is always going to be your X coordinate, which tells you how far left and right to go. And then the Y column will always be the second column, and that tells you how far up and down to go. And so we're going to graph these numbers as ordered pairs. In a scatter plot, we normally have just positive numbers since they're representing an actual value in real life. And so it's okay to graph just the first quadrant of your graph, where all the positive numbers are. Since this problem is a word problem and the numbers represent something, I'd like to point out a couple things that I did on my graph. On the x-axis, I labeled it with the words from the x column. So my x-axis is representing years since 1985. And then I also labeled my y-axis with my words from my y column, which is the percentages. Next, when I was deciding how big to make my graph and what numbers to count by, I looked to see what kind of numbers were in my table. And so for my X numbers, I noticed that I needed to get from 0 to 15. Now, I didn't feel like making a graph that went all the way up to 15. I thought that was kind of big. And so instead, what I did was I counted by threes. When you're numbering a coordinate plane, you have to make sure that your increments that you're counting by stay consistent. So if I'm counting by threes, I do want to count by threes every single time I hit a new line. I don't want to count by 3 and then only count by 2 and then count by 5 or something like that. You need to stay consistent. You don't have to count by the same numbers for your x-axis and your y-axis. You are allowed to choose a different number to count by for your other axis. And so when I'm looking at my y numbers, I notice that I need to get up to the number 20. So I need to make sure that I can get all the way up to the number 20. But I also notice that I don't really start at 0. The lowest number that I need to graph for y is 13. And so since I don't need anything below 13, I actually decided to put what's called a break into the graph. And you can see it right here. It's a little jagged line. And so I'm breaking the graph so that I can start at a higher number instead of having to graph all of those numbers that we're not even going to use. So if you want to break the graph, you can break the graph. And so to get from 13 to 20, it's not too bad. It's like 7 numbers, whereas this was like 15 numbers. So I decided not to count by threes for my y-axis. Instead, I decided to count by twos. Or maybe you even want to count by ones. Totally up to you. Again, notice that I counted by twos, 12, 14, 16, 18, 20. I did not just write down the numbers from my table. I chose an increment and I counted by that increment. Once you have your table all set up, properly labeled, properly numbered, then you can graph these as ordered pairs. Now that I've graphed my ordered pairs, I'm going to look to see which way they are trending. In a scatter plot, if the dots look like they are rising up, you would say it has a positive correlation. If the dots look like they are falling down, you would say it has a negative correlation. And if the dots are just everywhere, you'll say it has no correlation. For today's purposes, it will either have a positive or a negative correlation, because when we are drawing a line of best fit, it has to have one of those two. In this example, you can see that the dots are starting up really high, and then they slowly get lower on the graph. That makes this have a negative correlation. All right, that was the first part of the problem. Next, it wanted us to do some other stuff. It wanted us to draw a line of best fit. When you're drawing a line of best fit, there's a couple things to make your life a little bit easier, and a couple things that we have to do to make sure it really is the line of best fit. So when you're drawing a line of best fit, you want to make sure that you are drawing a line that is connecting two of the dots that were given as part of your data set. Because we're going to have to write an equation for this line, it's important that we have two ordered pairs so that we can write the equation. We need a minimum of two ordered pairs to write the equation of a line. The other thing you want to do when you're making sure that you are graphing your line of best fit, a line of best fit should divide the data so that half of the dots are above and half of the dots are below, and some of them are on. If you're drawing a line and all of the dots are above the line and none are below, that's not a line of best fit. So just make sure that you're getting it about halfway through the data. In this problem, I chose to use the two dots 318 and 1214. Okay, so 318 and 1214. So you can see I connected those dots. And I have two dots that are above that line and two dots that are below that line. So I've got two on, two above, and two below. I think that's pretty good. It's nice and evenly spread out. Once you've determined which 2 points you're going to use for your line of best fit, now you can write what's called a prediction equation using your two dots to write an equation for that line. We usually write our prediction equations in slope-intercept form. And this is actually what we were learning the past couple days, how to write an equation in slope-intercept form given two ordered pairs. So this is similar to our monster problem. So we always start this problem by finding the slope. After we found the slope, we can plug it back into the slope formula, and we can do cross multiplying. Notice again, and we've talked about this a couple times, but I really just want to make sure that I get it. Definitely, you guys really, really remember to put that negative sign with a number, right? So if you have a negative slope, really make sure that you're attaching it to just one of the numbers. So I attached it to the -4. Okay, I cross multiplied and distributed. I'm going to move my 162 over, and I'm going to divide by 9. This is my prediction equation. This is the equation for my line of best fit. Lots of different names for this, but yeah, this is my equation. Okay. Once you have your prediction equation or your line of best fit equation, then you can use that to predict the future. And so we're not predicting the future in this problem. We're actually predicting the past because 2010 already happened, but our books are not brand new. But so we're going to, we did not have data on how many students were applying to two colleges in 2010. And so I'm going to try to figure out, what do I think based on the data that I have? How many students do I think were applying to colleges in 2010? So I have my prediction equation. And we also need to notice we're not going to use the number 2010. Like it said that our X value was how many years after 1985. So we need to figure out how many years after 1985 2010 is, and it's 25 years later. So that means that my X will be 25. So I'm going to plug 25 into my prediction equation, and then I'll solve. I know that I'm going to need to add these two numbers together. And so I'm going to keep my over 9 so that, because then they already have a common denominator for when I eventually need to add them together. So I'm just going to keep them fractions for right now. And when I added them together, right, we did -4 times 25 is -100. -100 plus 174 is 74. And then 74 divided by 9 is about 8.22. And so according to the data that I have, and according to my prediction equation that I created, I think if the trend continues, that about 8.22% of students applied to 2 colleges in 2010. That's what I think happened based on the data that I was given. Just a little side note, we had a total of, I think, 4 answers to this question. We had a graph. We said it was a negative correlation. We wrote a prediction equation. And then we used our prediction equation to estimate something that we didn't have data on. So these scatter plot problems, they have many multiple parts to them. I could even ask you more follow-up questions. And so on your homework tonight, it's just going to be a single problem with like 6 or 7 different steps to it where you're writing out your answers to all these different problems. I'm going to pause for a second. I'm actually going to look up and see what that how many students applied to 2 colleges in 2010 so we can get an answer. So I'll be right back. I'm back. Unfortunately, I couldn't find that data, but maybe you guys can. If you do, let me know. That's it for now. Your homework over this weekend is one problem, but it takes up like a whole side of the worksheet. So make sure to do that homework, and I'll see you all on Monday.